again.
Maybe. Something like this. What would we do? Well, we're going back to what we were doing up here, where we had to do that. I guess it's further up than I thought. We had to find that least common denominator and multiply by it. Only here we have a few denominators. We've got 15, 9, and 6. We have to find our least common denominator of all those. You're thinking greatest common factor would be 3. Least common denominator would be bigger than them, but they all go into it. Like you'd have 30, but 9 doesn't go into 30. 60, 15 and 6 will work, but 9 doesn't go into 60. You have to go up to, the next one up would be 90. 15, 9, and 6 will all go into 90. Have I ever showed you guys how to find that by factoring?
The factoring tree?
Yep.
No, we do it tonight.
Not near as bad as you think. Very possible. Let's take 15. Here's 15 only factors into 3 times 5. So 15 equals 3 times 5. 6 factors into 2 times 3. And 9 just factors into 3 times 3. Least common multiple has to have all of the factors in it. But we don't have to repeat repeated factors. For example, 3 is in every one of these, right? So they all have a 3. So I'm going to circle that 3 in each of them. Just once, because it's only one. If there was 2 3s in all of them, I'd circle both 3s, but not every one of them has 2 3s. That's the only factor that's repeated. Well, now we have the 2, 5, and the second 3 that are left over. These two each need a second 3. So now they all have a 3, the second 3. Does that make sense? This one has a 2. These two need a 2. So now they all have that 2. This one has a 5, so these two need a 5. Now they all have a 5. Now all of them have all of the same factors. 3 times 5 is 15, times 3 is 45, times 2 is 90. 2 times 3 is 6, times 3 is 18, times 5 is 90. 3 times 3 is 9, times 2 is 18, times 5 is 90. 90 is the least common multiple.
It's a lot different horizontal. Never seen it.
Horizontally like that? It makes more sense to me that way, just so I can go down the list. But yeah, you just have to have all of the factors have to be there to have a least common multiple. So if you ever totally stump, that's one way to figure it out.
Couldn't you just quickly you get the 3 3s?
Yep.
And then just multiply 2 times 5 times 3? Isn't that in essence what you're doing?
Yeah. Getting 30 times the 3 that they had in common would be 90. Yeah, that's basically what you're doing. Yeah.
If you can't get that, can you still just go 15 times 9 times 6 times 3?
Sure.
Yeah.
Yeah,
It's going to give you, that's going to give you 810, which will work. Bless you.
I knew it. Like, instead of having a guppy, you're having got 0.
Yeah. Yeah, it works. Or the other way to do it, kind of like what Richard was saying, is you have this. And it kind of combines what you were saying, too.
I learned it different.
Oh, sure. You've got the 3 in common, so I'm going to circle it, so I'm only going to count that once. And so now, okay, 3 times 3 times 5 is 30. Then I'm only going to count this one once, times another 3. Usually that. Yeah.
They had it all drawn out in the tree shape.
Yeah. So now multiplying by 90, this is 90 over 1 times 4x plus 3 over 15. Now I'm going to have to add parentheses here, because that whole top gets multiplied. And I am going to cross cancel. 15 and 9 and 90 can both be divided by 15. Make this a 1 and this a 6. My denominators should cancel out here no matter what. That's why I chose the 90, the least common denominator. So now it is 6 times 4x is 24x. 6 times 3 is 18. This next one is where we have some major difficulties because of that thing. So this is really a negative 1. So this is 90 over 1 times negative 1 times 2x minus 3 over 9. Does that make sense? That minus in front is really a negative 1 times that. So I'm going to cross cancel the 90 and the 9 to give me 1 and 10. And then I'm going to do negative 1 times 10 is negative 10. So it's negative 10 that I'm going to multiply through. So negative 10 times 2x is a negative 20x. Negative 10 times negative 3, we get positive 30. And now finish on the left side of the equation. On the right side, 90 over 1 times 6x plus 4 over 6. Again, I put in parentheses. Oh, shoot. My sinuses are killing me today. Sorry about that. Cross cancel, I can divide out a 6 to make that a 1 and this a 15. 15 times 6x is 90x. 15 times 4 is 60. And then finally here I've got 90 times x over 3. The 3 and the 90 cross cancel give me 1 and 30, so 30 times x is 30x. Now what? Do some combining. 24 and negative 20, 4x. 18 and 30, 48. Over here, 90 and 30, 120x plus 60. Then what? What other one? That's where the 30x came from. So we'll subtract 4x. We got 48 here. 116x plus 60. And then subtract 60. Negative 12 equals 116x. And then divide by 116. So x equals negative 12 over 116, which reduces by 4, giving me negative 3 over 29. X is negative 3/29. Look like fun? No answer? Yeah. I won't do that to you a whole lot.
But you'll do it at least once.
Who knows? In a rain or on a train? How about something like this? Well, first thing I'd have to do, you'd look at that and you assume you're solving for x. But you do have to be told that I want you to solve that for x. Because there are 4 variables there. I could technically have you solve for any one of them. It's currently solved for c, because it's equals c, or c equals. But I want that solved for x, which means I want the x to be by itself. Now again, this is just like a lot of other equations we've solved. We have 3x plus 7 equals 22. How did we solve that? Well, we subtracted 7, right? Then we divided by 3. What are we going to do here? Well, we're going to subtract b. So that's gone, leaving us with ax. What's c minus b? C minus b. We just can't combine them because they're variables. They're letters. Then we're going to divide by a. Just like over here we divide by 3, here we divide by a. Leaving us with x. Well, c minus b divided by a. Remember we said it a couple of weeks ago, a fraction can be thought of as a division problem. A division problem can be thought of as a fraction. C minus b divided by a is just c minus b over a. What do you think? Good stuff? Yay? You almost sound like you mean that. Or you might have This one's a little bit cruel, but we have to get rid of one of the x's, right? Usually get rid of the smaller one. We have no clue.
A, B comes before D.
We just decide. We can pick whatever we want to. I'm just going to do this. I'm going to subtract the dx. So bx minus dx is just bx minus dx. Oh, very good point. I do have to tell you I want to solve for x. Good point. Now bx minus dx. If this were 7x minus 5x, we would get 2x. It's just 7 minus 5, right? And then times x. So bx minus dx is just b minus d, whatever those numbers are, times x. Does that make sense? Plus c equals m. Now, of course, I subtract c. So b minus d times x equals m minus c. And then what are we going to do? Divide by whatever that number is, b minus d. So x equals m minus c over b minus d. Good stuff. So what would we do with this one? Oh, good question. You caught me again. Solve for x. What's our first step going to be? Multiplied by c. Very good. Get rid of that. So multiplying by c makes that go away. What's d times c? dc or cd, however you want to put it. They both mean the same thing, right? But usually I'm going to put cd just because math grammar says you try to go alphabetical if you can. Next, add b. So ax equals what's cd plus b? What's cd plus b? Could be b plus cd. Either one is fine. Usually the alphabetical thing is only if they're multiplying. Like you would never have like 7yx. It would be 7xy when you're multiplying and put them alphabetically. But yeah, b plus cd would be the same thing there. Divide by a. X equals cd plus b over a. Pretty cool. Like that. So I'm going to have you guys do solve that for r. Not terribly tough, right? We divide by I. So yeah, v over I equals r. So r equals v over I. Not too bad. How about solve that for y? Py minus d equals m. That's technically not the equation, but the p and m are usually in your momentum equations. No. No,
It'd be applicable.
it would be. So we're going to add d. Py equals m plus d. And then perfect. Divide by p, y equals m plus d all over p. How about this one? Solve for I. Well, I have to get rid of the r, don't I? I'm going to divide by r. So this is p over r now equals I squared. So now I got to square root that to get rid of the squared. And I got to make sure that square root goes through the whole fraction. A lot of people just put the square root up like this. That doesn't work. That'd be the square root of p, then all over r, yeah. So yes, the square root and the squared cancel out. So I've got the square root of p over r over here, and over here I just have I. Where it can be kind of tricky, let's see. Solve that for C. Anybody see what the problem is here? C is in the bottom of a fraction. We've never solved for anything that's on the bottom of a fraction before. We got to get rid of that. We got to get it out of there before we can solve for it. If we multiply by C, that'll help. Right? So now C is gone. It's gone here. Over here, this is now L times C, right? And now he's got to divide by L. Yep. So C equals 4Q over M, all divided by L. I can simplify this sum. This is 4Q over M divided by L. I'm going to make that L over 1, so this is 4Q over M times 1 over L. 4Q times 1 is 4Q. M times M is ML. So C equals 4QML over ML. What do you think? You leave it as a triple decker? How about this one? I want you to try this one in your notes. No, you wouldn't get it wrong. See if you remember how to do that one. So where do we start? Well, times the 7/8. Get rid of that, right? So this is going to be 2/3 x minus 1/4. Here, the 4 and the 8 cross cancel goes 2 and 1, so we got 7/10. So we're going to add a quarter, add 1/4. So 2/3 x equals 7/10 plus 1/4 is, what's that? 19/20. Yeah. Then we are going to divide by 2/3. Which tells us x is 1 and 17/40. What's that? 2 and 11/80. Okay. 19/20 divided by 2/3 is 19/20 times 3 over 2. 19 times 3 is 57. 20 times 2 is 40. Nope, that's 1 in 17/40. You might have, yeah. That would do it. That would be 171 over 80. Yeah, 2 and 11/80. Yep, you're right. Solve that one for P. Maybe not quite this bad, but there'll be a couple of them on there. First thing here, the P is on the bottom, but we can't just multiply by P. Can anybody tell me why? Yeah, because it's R plus NP. So what I have to do is I actually have to multiply by that whole thing, R plus NP, to get rid of that whole fraction. Or that whole denominator of the fraction. So over here I now have I times R plus NP equals N over E. And now I'm going to have to multiply by the I. So this is IR plus INP. What was that? I could have divided by I, but that makes it a little bit more complicated if I do that. So I'm going to subtract IR. So INP equals NE minus IR. Then I'm going to, I'm solving for P, right? So I'm going to divide by IN. P equals NE minus IR over IN. Now, I would not do that to you on a tester quiz. On a tester quiz, probably the worst I would do to you would be something like this. We'll solve for V. Or I might do something like solve for L. So in your notes, do both of those quick. So let's look at the first one there. M equals FV squared for V squared. What's the first step? Divide by F, right? M over F equals V squared, and then square root. So it's the square root of M over F equals V. How many of you had that one? Good. The other one, P equals D squared over L, solving for L. First step is going to have to be, since L is on the bottom, to multiply by L. So this is now PL equals D squared, or LP equals D squared. The only reason I wasn't so worried about the order there is I know I'm going to do this next. I'm going to divide by P to get rid of the P. So L equals D squared over P. How many of you had that one? Cool. The other way you could think of that is this, especially if this is down here by itself. I can put this as P over 1, and now it's a proportion. And I can cross multiply and divide. 1 times D squared is D squared divided by P. So L equals D squared divided by P. So yeah, if it's just a single letter here and a single letter here, you can always just switch them. In your big book, page 392 to 394, it's exercise 15-4. I want you to just solve for the desired variable. That's just all these with the just letters and variables. There will be a quiz next week on this stuff, just so you know, coming up. Or at least on the solving the equations, not necessarily the ones that are all variables, but at least on solving the equations. Probably on Tuesday.